thrust? Thrust is a force which always acting perpendicularly on the surface of the object. Okay, and it depends like what is the area of the surface, surface area of the object, right? Now, if we talk about the unit of thrust is Newton. Okay, because this is a force, therefore the unit will be same, and it is a vector quantity.
Excuse me, ma'am.
Just a second. It is a vector quantity. Okay, so this is thrust. Now, what is pressure? For the heading, pressure. Okay, pressure is the force acting perpendicular on a unit area of an object. Okay, right? So write down, pressure is the force acting perpendicularly on a unit area of an object. Okay, so thrust is that total force which is acting on the surface area, right? But when we are saying pressure, this is the force acting perpendicular on the unit area of that object, and that is pressure. Is it clear? So write down, pressure is denoted by P. Okay, this is force per unit area. Okay, right? So this is capital F, this is capital A, and this is P. Okay, so write down P is equals to F upon A. Right? So how it is defined? How pressure is defined? It is defined as force per unit area. Okay. Now, what is the SI unit of pressure? SI unit of pressure. SI unit of pressure is Newton per meter square. Why? Because force is in Newton and area is in meter square, right? So it will become Newton per meter square. So this is how we can find out the unit of any physical quantity, right? So what is the unit of pressure? It is Newton per meter square, and this Newton per meter square is also called as pascal. What it is called as? Pascal, right? Denoted by P and small a, right? Okay. So what is the unit of pressure? It is pascal, right? And it is named after the scientist Blaise Pascal. Okay. So 1 pascal is 1 PA is 1 Newton per 1 meter square. Is that clear? So this is a pressure is a scalar quantity. So write down, pressure is a scalar quantity. Do not have any direction, right? Force is vector quantity, but pressure is scalar quantity, right? So if you see this formula, P is equal to F upon A, right? It is clear that the same force can produce different pressures. Yes or no? If force is same, but area is different, it can create different pressures depending upon the area on which it is acting, right? Is that clear? So same force can create different pressure depending upon the area, right? So if force is acting on a smaller area, it exerts a large pressure, while the same force acting on the larger area exert smaller pressure, right? So write down, pressure is proportional to force, right? But pressure is inversely proportional to area, right? So if area is increased, pressure will decrease for the same force. Is that clear? So if the same force is applied, but area is less, then pressure will be greater, right? In comparison to the same force which is applied to the large area will create small pressure. Is that clear? Why? Because pressure is inversely proportional to area. Okay. Now let's see some questions based on it. Question number 8. Force of 200 Newton is applied to an object of area 4 meter square. Find the pressure. Okay, so how to do this question? So first, see what is given in the question. Force of 200 Newton means force is given. So write down what is given to us. Force F is 200 Newton. To an object of area 4 meter square, right? Means area is given. Okay, so write down A means area, that is 4 meter square. Now, we know that what is pressure? Pressure is force per unit area, right? So force, first write down the formula F upon A, right? Force is 200 Newton and area is 4 meter square. Since both are in their SI units, so no need to convert them, right? Unit is already SI units. So we write them as it is, right? 200 upon 4. So this is equals to 50, right? Newton per meter square, right? So what is pressure? 50 Newton per meter square, or you can say it is 50 pascal, PA. Is that clear? Okay. So in this way, we can find out the pressure, right? So how much pressure this force will create on an object whose area is 4 meter square? That is 50 pascals or 50 Newton per meter square. Is that clear? No. Another question. Look at here. Question number 10. Question number 9. So look at this question.
10, ma'am.
A woman is wearing sharp-heeled sandal. Okay. And the mass of woman is 60 kg. Area of one heel is 1 centimeter square. Find out pressure exerted on the ground when the woman stands on just one heel. Okay. So she's standing on just one heel. And what is the area of the heel? 1 centimeter square, right? So when she is standing on the ground with one heel, right, she must be putting some pressure on the ground, right? So we have to find that pressure here, okay? So very first, write down what is given in the question, okay? So now in this case, the force will be the weight of the woman, yes or no? So where the force is coming now to create the pressure? This force is coming from her weight, right? Yes or no? So what is weight? Weight is the force, isn't it? So here the force will be the weight of the woman. Are you getting that? Force will be the weight of the woman. Okay, so first we will find out the weight, right? So what is the mass M given here? Mass of woman is 60 kg, right? And G is given here 10 meter per second square, acceleration due to gravity, right? Now we know that force, which is weight here, weight is equals to M into G, right? Getting that? Okay, because here acceleration is the acceleration due to gravity, right? So mass is 60 kg into G. G is 10, right? Okay, so what will be the weight? Weight is 600 Newton. So this weight is the force which is exerted. Okay, are you getting that? So this is the weight, or you can say the force, right? Okay. Now, area. Area is also given. What is the area given here? Area of one heel is 1 centimeter square. Now look at this area. This is given in centimeter square. But what is the unit of area? SI unit of area, as I told you? SI unit of area is meter square, right? So it should be in meter square, but it is given in centimeter square. So what we need to do? We have to convert this centimeter square, right? We have to convert this centimeter square into meter square, right? Okay. Then only we can put this value within the formula, right? So we will divide this with, because this is centimeter into centimeter. There are 2 centimeters. So every centimeter need to be converted into meter. So 1 centimeter is equals to 1 by 100 meter, right? Since there are 2 centimeters, centimeter into centimeter, so we have to divide with 1 upon, we have to divide with 100 into 100 meter square. Is that clear? Okay, so this will be the area. Now we will use the formula. Pressure P is equals to force upon area, right? So this time what is your force? Your force is the weight, right? So this is 600 Newton upon 1 upon 100 into 100, right? Is that clear? This is the area. Now this term will go at this side, okay? Because it's a fraction upon fraction. So 600 into 100 into 100. So what is the pressure it will create? It will exert on the ground. Pressure exerted will be on the ground is 1, 2, 3, 4, 5, 6. 6 into 10 to the power 6 Newton per meter square. Is that clear? Or other way, you can say that pressure is 6 into 10 to the power 6 Pascal. Is that clear? Right? In Pascal, it will be, we can write down in terms of Pascal if we are not writing in Newton per meter square. Is that clear? Okay, so what is the pressure? So now you can write down, thus the pressure exerted by the woman of 60 kg standing on only one heel of area 1 centimeter square is 6 into 10 to the power 6 Pascal. Okay, so this is your answer. Now, if suppose in the question, it is given that she is standing on both of her heels, right? Here it is given that she is standing on just one heel, right? So that's why we are using the area of one heel only, which is 1 centimeter square. If suppose she is standing with both of her heels, then what we will do? We will add the area of both the heels. So 1 centimeter square plus 1 centimeter square. So what will be the area in that case? 2 centimeter square. Is that clear? So in this case, the area will be doubled. And what will happen to the pressure? What will happen to the pressure? It will increase or decrease? Can you tell me? What will happen to the pressure if area is increased? Okay. So what will happen if we increase the area? Because area will get double, so pressure will become half, right? So if you find out pressure in that case, if she is standing both of her heels, then pressure will be half, right? It will decrease. Why? Because area is increasing, right? So pressure and area both are inversely proportional to each other, right? If area is increased, pressure will decrease with the same ratio, right? If area is double, pressure will get half. If area is 3 times, pressure will get decreased by 3 times. Is that clear? Okay.
Yes, ma'am.
Force remains same because her weight is same. Weight is not going to change, right? So weight is like 60 kg, mass is 60 kg, 60 into 10. So 60 will not going to change. And gravitation, acceleration due to gravity will also remain 10, right? So it will remain 600 only. The force she is exerting will remain same, right? But pressure she is creating will decrease, right? So this is the, just look at this, like what is the beauty of these relations which scientists have found it out, right? So with the same force, pressure can be different. Force is applying is same, but pressure is different, right? And that's the reason when uh, you try to you have to put that nail on the wall, and you are hit it with the hammer, that nail can enter into the wall or into the wooden block easily. Why? Because it is very pointed at the tip, right? So since it is pointed, it's like this. Yes or no? It is like this, right? Yes or no? So when you just apply the force from here, what will happen, right? So this point is very, very less. This is having a very small area. So if area is less, right? Okay, the force which you are putting here, which you are exerting on the nail, right? That is enough to fix that nail into the wall, right? Otherwise, try to hit the wall with the hammer with the same force. Will you be able to get, anything like any brick you can break from the wall? No. Why? Because area is more, right? Therefore, pressure will be less, right? But here, when you are hitting it with the hammer, since area is very, very small, this is very pointed, it is very sharp here, right? So since area is very small, the same force can create a big pressure, and because of it, this nail can fix into the wall. Are you getting that? So these are all applications where we are using these things. Is that clear? Okay.
Yes, ma'am.
We can have more applications, right? Applications of pressure. So you can write down few applications of pressure. Buildings are provided with broad foundation, right? Buildings are provided with broad foundations, right? Why? So that the pressure exerted on the ground becomes less, right? So to increase the area on which that force is exerting by the big structure, right? Similarly, railway tracks. Railway tracks are laid on cement or iron sleepers, okay? On cement or iron sleepers, you can see there, right? Why? So that the pressure exerted by the train could spread over the larger area and thus pressure decreases, right? Because the train is very, very heavy, right? Similarly, pins, needles, and nails, right? They are provided with sharp, pointed ends, right? Sharp pointed ends, right? To reduce the area, right? To reduce the area, and hence pressure will increase. Is that clear? And so that they can easily fix into the wall or in the board, right? Cutting tools. Have you seen the cutting tools? What kind of edge they are having? They are having very sharp edges, right? Cutting tools have sharp edges. So what is the reason behind? To reduce the area. So when the area is reduced, with the lesser force, more pressure can be created and it can easily cut the log, right? Okay. Then tractors. Have you seen the tractors? Tractors have broad tires, wheels. Yes or no? Right? So to create less pressure on the ground, so that tires do not sink into the comparatively soft ground in the fields. In the agriculture fields, the ground is soft, right? Okay, so that can create a less pressure. Is that clear? The tractors have broad tires, right? So these are certain applications of pressure where it is increased or decreased as per the demand. Is that clear?